As you look into the night sky, hopefully you are mesmerized by what you see before your eyes. But maybe you also ask yourself some questions, and maybe you stop to think and you pause on some great wonders of the world, and you ask yourself questions such as, what is the distance from the Earth to the Sun? How long would it take that light to reach me? How long would it take me to run there? How long would it take ET to cycle there? Maybe you ask questions like, how do scientists know how many stars there is in a galaxy? How would they be able to tell that when they've never actually been to those stars? Or maybe you simply look up into the night sky and you maybe see something passing and whizzing around. You wonder what it is, and if it's a spaceship, you wonder, what is the point of space exploration, and is it indeed all those millions and billions of dollars worthwhile? Well, we won't be able to answer all those questions today, but hopefully in this video we'll answer at least one of them. So when we look up into that night sky, we can see lots and lots of things, and we can see lots of movement across the sky. And this is a very normal thing. Everything in the universe is moving. And we're going to talk about that motion, I guess, in greater detail in other videos. But so let's just talk about some of the things that we see in the night sky. And we're going to zoom in and just have a look at some of those. In the night sky, of course, we may not... or we will not necessarily see our sun, which we've got here. So we're just going to maybe park that, and we'll get back to that conversation later. The sun would be behind us. It would be an obstructed view. So we're going to start by zooming out and moving out to, I guess, the closest natural body of significance beyond our Earth, and that is the moon. It's the only place that humans have been that isn't Earth, and maybe in the future, who knows, maybe we may end up having to set a little colony there. So the moon is a natural satellite, and it's a natural satellite. It's so called a satellite because it actually orbits a bigger body. So it's a natural satellite. Now this word orbit means that it moves around a larger body. The larger body in this case being our planet. And many planets have moons. Some planets have many moons. The inner planets tend not to have any moons, and the outer planets, the gaseous planets, can have lots. And some of those planets like Jupiter have really large moons, such as Ganymede, that are larger than some of the smaller planets in our solar system. Now we're just going to continue moving around here. We're going to zoom out, and then we're going to zoom in. And sometimes in the night sky you see something flashing across the sky like this really fast. And what you might be looking at there is an example of something called a comet. And a comet is an icy small solar system body of dust. So this is called what we know to be a comet. And this is an icy solar system body of dust that heats and releases gases as it passes close to the sun. So as it enters the Earth's atmosphere and it gets closer to the sun, it heats up, and you start to see this orange-red tail as that ice and dust burns up. It starts to show as the energy is given off. It shows in that coloring. So we might also see some planets in the distance. We can, from time to time, we can certainly see Venus. Maybe we might see the red planet of Mars. What else can we see? We might see in the distance. We might see this here. So we're just going to zoom in and have a look at what this is. And what we would be looking at is maybe Andromeda galaxy. And this is a galaxy that's 2.5 million light years away. So there's a lot in that. What does this mean, 2.5 million light years? Well, we're going to talk about what that means. And it is the furthest thing that you can see with your eyes. It's also got a nice elliptical shape. And a galaxy is a collection of stars, gas, and primarily empty space. Our own galaxy that we sit within is called the Milky Way galaxy. So in the rest of the video, we're going to look at the subject of scale, and we're going to look at the enormous distances that we're talking about when we talk about our universe. So we're going to start close to home, and we're going to look at the solar system. And we're going to talk about those relative distances. And often when we look at photos of the solar system, it doesn't do a good job of scaling this. And what can be lost from students sometimes is that these 4 inner planets are actually quite close to the sun in terms of distances. So the 4 inner planets. And when we look at the outer planets, you'll see that distance-wise, this is more to scale. These are the outer planets. They're sometimes called the Jovian planets. The outer planets are made of gas. The inner ones are terrestrial. And when we look at this, we can see that the outer planets, the distances between them is quite large in comparison to the inner planets. We would also notice the presence of some rings around these outer planets, and we notice the relative differences in sizes of those outer planets. So how could we measure the distance between these distances between these planets? And clearly kilometers or meters or indeed the inch or foot isn't going to quite cut it here. So we're going to move across here and we're going to explore the notion of an atomic astronomical unit rather. So an astronomical unit, put quite simply, is the distance between the Earth and the Sun. The distance between the Earth and the Sun. And when we're talking in terms of astronomical units, that distance between the Earth and the Sun is quite a bit. It is 150 million kilometers. So to put that into context, if you're driving in a car, a 200 or 300 kilometer run would be a good journey. Well, this is 150 million kilometers, and that is equal to 1 AU. So this unit of 1 AU is set. So what do some of these AU values look like? Well, we're just going to move over here and have a look at this. So you'll see a couple of things here. Earth, of course, the AU distance between Earth and the Sun is set as 1. And we'll also notice that these ones, the inner planets inside the Earth, in between the Earth and the Sun, are less than 1, obviously. And we'll also notice that these outer planets, these 4 outer planets, that the AU distances here are starting to increase pretty rapidly. So AU is a very good indicator of distances. It's a very good unit to use because the numbers are 1, 5, 9, 19, much more easier numbers to grasp than other units would be. And just to show a visual of that change in relative distances, as we move out from the Sun, we'll see that the AU is getting much, much larger, and it pretty much follows an exponential curve. So now that we know a little bit about an AU, let's put this into some context that we can work with. Okay, so the question might be, how long does it take the sun's light to reach our eyes? This light from the sun. This was a question that one of the questions we began with. Well, we know a couple of things. We know that 1 AU is 150 million kilometers, and we know that the speed of light is 300,000 kilometers every second, the fastest thing in motion that we know of in the universe. And so if we simply put our AU and we divide it by the speed of light, our kilometers will cancel and we'll get what we need in seconds. So of course we can cancel out these 4, 5 zeros, and what we would get here is we would get 1500, my zeros are slightly off there, divided by 3, and that would give us an answer in seconds, which is 500 seconds. So this is how long it takes that light energy from the sun to reach our eyes. never look directly at the sun, it could hurt your retina, but it would take 500 seconds. So if you think about it, looking at the sun or towards the sun, you're looking 500 seconds back into the past, which is just over 8 minutes. So you're able to see 8 minutes into the past. Now, to answer the question, how many hours would it take ET to reach the sun if cycling at 100 kilometers per hour? Maybe stop the video and have a little bit of a think about that one. So in order to figure this one out, we're going to have to work on our mathematics, and we're going to have to figure out, okay, we've got ET. We know how quickly ET can go, and we know the distance that we need to go is 150 million kilometers. And if we divide that by 100 kilometers per hour, well, we're going to do our cancelling again. And we're going to see that we get 150, 1, 2, 3, 4. And so what we see is that it would actually take 1.5 million hours. So, you know, ET is going to have to develop some sort of warp speed mode of getting there. Otherwise, it ain't happening. So speaking of light, light would be a very good thing to base our measurements off, because it travels at a constant known speed. So the question might be, if light can travel 300,000 kilometers every second, how far would it travel in a year? Well, of course, we'd need to take this and we'd need to multiply it by 60 to get our minutes, and then we'd need to take that and multiply it by 60 to get our hours, and so on, and then 24, and we would need to multiply that by 365. And what we're going to end up with, of course, is a very large number. And this number down here represents the distance that light travels in 1 year. So we're going to call that 1 light year. 1 light year. So this is the distance that light travels in 1 year. And if you stop to think about how big this is, it's 9.46. If we would need to multiply that by 1 and 12 zeros. And that's how many kilometers it would be. So an enormous difference, much bigger figure than astronomical units. So just to get an idea of how many light years away certain things are, the source of this graphic is from NASA. So just to give you an idea, the sun, well, we talked about that, it's 8.3 light minutes away. We're not dealing in light years here. The North Star, which we call Polaris, which sits in the sky above the North Pole and does not move, is about 320 light years away. The closest neighboring galaxy, Andromeda, is 2.5 million light years away. So as big and all as light years are, we can see that the nearest galaxy is 2.5 million light years away. A little bit closer to home, Proxima Centauri, our closest neighboring star after the sun, of course, is 4.3 light years away. So if you could move at the speed of light, it would take you 4.3 years to reach it. So a light year is an extremely big unit of distance. And let's put this all into perspective again and just recap what we know. If we're talking about things in the solar system, then we should probably use distances in the AU. And we said that 1 AU was the distance between the Earth and the Sun. And so it's very useful for distances in the solar system where centimeters won't cut it. If we're talking about beyond the solar system and we move past this thing, which is called the Oort cloud, then we're going to start using these measurements of 1 light year. So hopefully that this video gives you a better appreciation for the distances, the size scale of our beautiful universe, and some of the things within the universe. If you like this video, just give me a wee thumbs up, please.